Let's continue exploring changes in Git repository after first commit in BR1 branch. Here above we have seen contents of commit object that was made in BR1 branch. And here is pointer to tree object, and here is its SHA-1 hash. Let's copy part of this SHA-1 hash and let's explore contents of the tree object. Git cut file, -p and paste copied SHA-1 hash. Enter, and here are contents of this new tree object. And here we see link to one blob. Here is a name, file name for this blob, and here is SHA-1 hash for this blob. Let's have a closer look at this SHA-1 hash. Did we see it before or not? Of course, we have seen it, and we have seen it in the very first commit in our project. Let's go to Finder actually, and let's explore contents of the objects folder. And notice that Git has created two folders, this one and this one, today. Inside of this first folder, starting with 0b, Git has created actually this tree object we are exploring now. SHA-1 hash starts here with 0b, 7a and so on. And inside of this folder, 28 in my case, Git has created commit object. We can look at it again, git log, and here is SHA-1 hash for this commit object. It starts with 285b, and that's what I see here, folder 28 and file that starts with 5b. But there is no third file that was created here in Git repository. Git has created only two objects, here and here. Let's have a look at this file with this SHA-1 hash, starting with b7ae. Let's go back to Finder, and here is this folder, b7, and here is file inside of this folder. And you see that this folder was created several days ago in my case. And this folder contained blob with hello git string. Actually, we can prove that. Let's go back to command line and use git cut file, -p. Actually, let's check type first, and let's copy this SHA-1 hash, paste here, enter, and yes, it is blob. And let's now explore contents of this blob. Instead of -t, let's type -p, enter, and yes, we see hello git. What does it mean? It means that Git has reused existing blob. Even if file name is different, we have created new file, file4.txt, with same contents as file1.txt that we have created before. In order to fully clarify what happened here, let's have a look at this diagram where I have shown all commits that are created at the moment, all trees and all blobs. Here is first commit made in BR1 branch, here is tree object that this commit points to, and here are links in this tree object. This tree object points only to one file, file4.txt. And contents of this file are the same as contents of the file 1.txt, this one. That's why Git has simply reused existing blob, even if file name is different. That's because file names are stored in the trees, and there is no need to create new blobs with same contents. More than that, you know that every file that is created in objects folder has file name that is based on SHA-1 hash of the contents of the blob. And if contents are the same, SHA-1 hash will be the same as well. And in your case, SHA-1 hash for this blob should be the same as here. It starts with b7ae. And again, Git has simply reused this blob even if file name is different. And if I'll check out this first commit, you'll see same SHA-1 hash in this tree that starts with b7ae. Let's actually do that quickly, and let's quickly check out this first commit. Let's go back to command line, type here git log, enter, and let's copy SHA-1 hash of this very first commit. Copy, close this, and let's check out this commit. Git checkout, and paste copied SHA-1 hash. Enter. We are in detached head state now. Here is SHA-1 hash of this commit. And let's list files in working directory. ls, enter, and here I see file1.txt and file2.txt. Let's have a look at contents of file1.txt. Enter. And here I see hello Git, of course. Let's observe contents of this commit object. Copy is sha1 hash, git cut file -p, paste copied sha1 hash. Here is pointer to tree object. Let's copy this sha1 hash and explore this tree object. Git cut file -p and paste copied sha1 hash. Enter. And here are two pointers to two blobs, file1.txt and file2.txt. And here you see exactly the same sha1 hash as we have seen for file4.txt in the last commit. And that proves that Git has simply added pointer to existing blob. Let me show entire picture like this, and let's summarize. We have created new branch br1, and we have made first commit in this branch. And Git has created in Git repository commit object, this one, and this tree object. But Git has reused existing blob object, this one. That's because contents of file4.txt are the same as contents for file1.txt that was created here at the beginning of our project. Now we have two branches in our project, and we can easily switch between those two branches and create different commits in different branches. Let's go back to command line and let's actually check out again br1 branch, because now we're located in the detached head state. Git checkout br-1, enter. And now we are again at br1 branch. Let's list files in working directory, ls, enter, and now I see only one file, file4.txt. Let's change branch to master, git checkout master, enter, and let's list files now, ls. And I see nothing. That's because in last commit, third commit in master branch, we have deleted all files from working directory. And that's how you can easily change versions of your project. Here is version in br1 branch, and here is version in master branch. Okay, now you know how to create new branches, how to create new commits inside of the branches, and how to check out different branches and commits. Now it's time to move on to the next section, where I'll show you how to clone remote repositories and how to explore real-world projects created by other people. Let's talk about all of that in the next section. I'll see you there. Bye-bye.